Hello friends, today we will study about the screw gauge. Screw gauge is a device used to take precise measurement of very small linear dimensions, for example diameter of a wire, diameter of spherical balls and thickness of sheets etc. It was invented by William Gascoigne in 17th century. Screw gauge is based on the principle of micrometer screw. So to start with, let us discuss some major parts of a screw gauge. Screw gauge consists of a U-shaped metallic frame. On the left side of it, we have a metallic projection which is known as the stud. The second stud is known as the spindle. So between these two, we place the object to be measured. So this spindle is then connected to a barrel shaped part which is also known as the sleeve, and this sleeve is graduated. We have marking in millimeters over it. So this is over this we have another important part which is known as the thimble. This thimble is tapered on one side and is divided into equal divisions. So in this particular case, we have 50 divisions on this thimble. This is it also known as the circular scale. Then connected to the thimble, we have ratchet. Ratchet is it avoids the unnecessary tightening of the studs. So to move ahead, let us discuss one more important thing. This is the horizontal line. This horizontal line is known as the reference line. It is important because all the readings of the circular scale are taken with the reference to this line. So to move ahead, we will first discuss two important terms about this, that is the least count and the zero error. So least count is the minimum distance a screw gauge can measure without any error or with full confidence. The least count of the screw gauge is defined as pitch upon number of divisions on the circular scale. Now the question is, what is pitch? So pitch is the linear distance traveled by the circular scale in one complete rotation. So let us say we give 4 rotations to it and let us see how much distance it travels. So this is one rotation, 2, 3 and 4. So on giving 4 rotation, it has traveled 2 divisions on the main scale which is equal to 2 millimeters. So 2 millimeters it travels in 4 rotation. So for one rotation, 2 upon 4, that is 0.5 millimeter. So the pitch of this screw gauge is 0.5 millimeter. So there are 50 divisions on the circular scale. So we can now put the value there in our formula. So it is 0.5 upon 50, and that is equal to 0.01 millimeter. So 0.01 millimeter is the least count of our screw gauge. So now for the zero error. To calculate the zero error, we keep these two studs in contact so that nothing in between, and then look for the zero of the circular scale. As we can see that zero of the circular scale has gone up with the with reference to the reference line. So this is our this case in which you can see it here clearly, that is zero of the circular scale is above the reference line. So this type of error is known as negative zero error. Now when zero of the circular scale coincides with the reference line, we say that there is no zero error or the screw gauge is free from any zero error. When the zero of the circular scale is below the reference line, that time the zero error would be positive. So we have seen these two types of zero errors and the case of no zero error. So now the question is that if it suffers from zero error, how much is the zero error and how will we account for it? So we will see that how many divisions it has gone up or it is below. So we'll count the number of divisions from 0 with up to the reference line. So in this particular case there are two divisions. So zero error is equal to circular scale division multiplied by the least count. So there are two divisions. So we can write 2 into 0.01. So that is millimeter. So that is 0.02 millimeter is the zero error with positive sign, because in this particular case it is positive zero error. Now look for the negative zero error in this case. So zero error is again defined as circular scale division into the least count. Now let us see how many divisions. So start counting from the 0 up to the reference line. 1, 2, 3, 4. So there are 4 divisions gone up. So 4 into 0.01 millimeter. So that gives you 0.04 millimeter with a negative sign because our zero error is negative. So this is how we calculate the zero error in case of the screw gauge. So now let us calculate the diameter of this pencil. I have taken the pencil to be more observable. So we will fix this between the two studs, and then we will see that what is the main scale reading and what is the circular scale reading. So the formula is observed reading is equal to main scale reading plus circular scale division into least count. So here just concentrate on it. You can see that there are 7 divisions which the circular scale have crossed. So our main scale reading would be 7 millimeters, whereas if we look for the circular scale division, so it is the that division which coincides with the reference line. So in this particular case it is 34th division which is coinciding with the reference line. So now see how much is our observed reading. So it is 7 millimeter. Main scale reading is 7 millimeter. So it is 7 millimeter plus 34 into 0.01, which is the least count in millimeter. So that gives you 7 plus 0.34, that is 7.34 millimeter is the observed diameter of the pencil. Now as we know that our screw gauge was having a negative zero error, so let us put that zero correction in it. So our actual reading will be observed reading minus zero error, where zero error is to be kept with proper sign. So we see that our zero error was minus 0.04. So it means that actual reading would be 7.34 minus 0.04. So that gives us 7.34 plus 0.04, that is 7.38 millimeter. So this is the corrected diameter of the this pencil. Now to be more accurate, what we can do is we can take a number of readings of this diameter in different directions. So suppose we take 4 readings in 4 different directions, in xy direction other. So and then average it out. So this reduces the further error if there is any and we get a good, means more accurate or a precise value of diameter. So thank you and have a nice day.